Okay, this first problem is the which of Ignacy problem, which involves an equation that looks like this one. So this is just one example of a which of Ignacy problem. So we want to find the equation of the tangent line to y equals 8 over x squared plus 4 when x equals 3. And there are a couple different ways that we can do this. We definitely, to get an equation of a line, we're going to need the derivative at this point. So the derivative at x equals 3, and then we're also going to need the point when x equals 3. So let's start with the derivative. So dy dx, we can either do the quotient rule here, or we can move this up and give it a negative exponent, so we could rewrite y as 8 times x squared plus 4 to the negative 1 power, and then use the chain rule. I'll show that way. So if we do dy dx here, we're going to pull down the exponent, so that would be negative 8, and then this x squared plus 4 to the negative 2, and then chain rule says now we have to do the derivative of the inside, so multiply that by 2x, which is the derivative of this inside. Okay, so that would give us negative 8 times 2x on top, so negative 16x over x squared plus 4 squared. And you would get the same thing by doing the chain rule, or by doing the quotient rule. We just did this with the chain rule. So now we need the derivative at x equals 3, so let's plug in 3 to this equation. And we would get negative 48 over 3 squared plus 4 is 13 squared, so negative 48 over 169. So this is the derivative, so that's going to be our slope. Okay. So to find the equation of the line, we need the slope and a point on the line. So let's find a point on the line where x equals 3. So that means like the point at which we're tangent. So we need to find the y value that goes with x equals 3. So that means just plug in x equals 3 into this formula. So that would be y equals 8 over 3 squared, so 9 plus 4, so 8 over 13. So our point on our line is going to be x comma y, so 3 comma 8 over 13. Okay, and then to get the equation of the tangent line, we're going to use that slope and the point, so y minus y1 equals m x minus x1. So that will be y minus 8 over 13 equals the slope, which is negative 48 over 169 times x minus 3. And that's our equation of our tangent line. So anytime you're asked for a tangent line, you need a slope and a point. To get the point, just plug in the value that you're given, and to get the slope, you need to find the derivative at that x value. Okay, another homework problem. Let's find the derivative of f of x equals 4e to the x over 5x. This is one where we're going to need to use the quotient rule. So here's the top of our function and the bottom. And we can say u over v, the derivative of that. Just a rewriting of the quotient rule with u and v instead of f and g. is equal to v u prime minus u v prime divided by v squared. Okay, so I like to first find all of those functions. So u is just the top function, so 4e to the x, and then u prime is going to be the derivative of 4e to the x, which is just 4e to the x. V is the bottom function, so 5x. The derivative of 5x is going to be 5. So let's plug those into this formula. So f prime of x is going to be v, so 5x, times u prime, so times 4e to the x, minus u, which again is 4e to the x, times v prime, which is 5, divided by v squared, so divided by 5x squared. And we can simplify this a little bit. So on the top, we have 20x e to the x minus 20 e to the x. And then in the denominator we have 5 squared is 25, x squared is x squared. So here's our function for f prime of x. Okay, here's another tangent line equation. Find the equation of the tangent line of f of x equals 1 over x to the third at x equals 1. So again, to find the tangent line, we need the slope at that point, and then we need the point on the equation at that point. So let's first find the derivative, because that's how we get the slope. But before we do that, I'm going to rewrite f of x as a negative exponent instead of as a quotient. So I'm going to rewrite f of x as x to the negative 3. So whenever we have a positive exponent in the denominator, we can flip it up and make it a negative exponent in the numerator. Okay, now we can find the derivative using the power rule. So f prime of x will be, bring down the power, negative 3x to the negative 4. And let's find f prime of x at 1. So f prime of 1 is going to be negative 3 times 1 to the negative 4 power. 1 to the negative 4 power is 1, so this is just negative 3. So that is our slope of our line. And then let's plug in x equals 1 to get our point. So this here gave us our slope. Now let's find our point. That means we're going to plug in x just to the original equation, so f of 1, which would be 1 over 1 to the third, which is 1. So our point is 1, 1. Okay, now we can take that point and that slope and plug it into y minus y1 equals m times x minus x1, which is going to be y minus 1 equals negative 3 times x minus 1. And that is the equation of our tangent line.